Today's mobile-first world, security is more than just a feature. It's the foundation of trust, especially for banking apps. As digital transactions become the norm, protecting sensitive user data is crucial. This video will guide you through building a secure app lock for Android banking apps, covering everything from architecture to best practices. Whether you're an experienced developer or preparing for a fintech interview, mastering app lock implementation is essential. Let's dive into the essentials of creating a robust security layer that not only meets regulatory standards, but also earns user confidence. Banking apps handle highly sensitive information, making them prime targets for unauthorized access. AppLock acts as a second layer of defense, ensuring that even after a user logs in, their data remains protected. This mechanism prevents unauthorized access when the app is reopened and helps comply with strict regulations like RBI and GDPR. By implementing AppLock, you not only protect your users, but also build trust and credibility for your app in the competitive fintech landscape. A well-structured project is key to maintainable and scalable app security. In a typical multi-module clean architecture setup for banking apps, responsibilities are separated into modules like app, presentation, domain, data, core, and biometrics. This modular approach keeps your app lock logic isolated, making it reusable and easier to test. By organizing your codebase this way, you ensure that security features are robust and can evolve independently as your app grows. The app module is the entry point of your Android application. It handles app startup, dependency injection, and navigation between screens. By centralizing navigation and startup logic here, you can ensure that security checks like app lock are consistently enforced across the app. This module acts as the glue, connecting all other modules and orchestrating the user experience from launch to secure authentication. Presentation module manages the user interface, including activities, view models, and Jetpack Compose components. This layer is responsible for displaying the app lock screen, handling user input for PIN or biometric authentication, and updating the UI based on authentication results. By keeping UI logic separate, you ensure that security flows are clear and user-friendly, while business logic remains decoupled and testable. The domain module contains your app's business rules and use cases. Here, you define contracts for app lock, such as authentication flows and session validation. By abstracting these rules, you make your security logic reusable and easy to test. The domain layer acts as the backbone, ensuring that all security-related decisions are consistent and centralized, regardless of how the UI or data layers change. The data module manages repositories and data sources, including secure storage for PINs and session tokens. By using Android Key Store and encrypted shared preferences, you ensure that sensitive information is stored securely and cannot be easily accessed or tampered with. This layer abstracts away the details of data storage, allowing the rest of your app to interact with secure data through clean interfaces. The core module contains common utilities, constants, and security logic shared across your app. By isolating app lock logic here, you promote reusability and maintainability. This module can include encryption helpers, lifecycle observers, and other foundational tools that support secure authentication throughout your app. The biometrics module handles all logic related to biometric authentication, such as fingerprint or face recognition. By keeping this logic separate, you can easily update or extend biometric features without affecting other parts of your app. This clean separation ensures that your app remains modular and adaptable to new authentication technologies. A secure app lock must be aware of the app's lifecycle. By detecting when the app moves to the background or returns to the foreground, you can trigger the lock screen at the right moments. This approach ensures that sensitive data is protected even if the user switches apps or leaves their device unattended. Implementing lifecycle observers helps automate this process, making your app both secure and user-friendly. Based authentication provides a familiar and secure way for users to unlock their banking app. By storing and validating the PIN using Android Key Store and encrypted preferences, you ensure that the PIN cannot be easily extracted or brute forced. This method adds a strong layer of security, especially when combined with other authentication factors. Integrating biometrics, such as fingerprint or face recognition, enhances both security and user experience. Android's Biometric Prompt API allows seamless integration, letting users unlock their app quickly and securely. Biometric authentication should always be paired with a fallback like PIN to ensure accessibility and compliance with security standards. For banking-grade security, combine multiple authentication factors: biometrics, something you are; PIN or password, something you know; and device binding, something you have. This multi-layer approach makes it much harder for attackers to gain unauthorized access, even if one factor is compromised. Each layer adds depth to your app's defense strategy. Device binding ensures that only the registered device can access the user's session. Using SafetyNet Attestation or Play Integrity API, you can bind the session to the device, adding another layer of protection. This step is crucial for preventing unauthorized access from cloned or tampered devices. For sensitive actions like fund transfers, step-up authentication using OTP, one-time password, adds an extra layer of security. Triggering OTPs via SMS or email ensures that only the legitimate user can complete high-value transactions. This method is effective for preventing fraud and unauthorized transfers. Session validation is essential for maintaining secure user sessions. Store session tokens securely using encrypted storage and invalidate them after a period of inactivity or when the app goes to the background. This practice helps prevent unauthorized access if a device is lost or left unattended. The authenticator chain pattern validates each authentication layer in sequence, ensuring that all security checks are performed before granting access. This approach makes your authentication flow robust and modular, allowing you to add or update factors without disrupting the entire system. To prevent app lock bypass via recent tasks or screenshots, use the Flag Secure window flag on all sensitive screens. This prevents content from being captured in screenshots or recent tasks previews. Additionally, monitor the app's lifecycle to trigger app lock reliably whenever the app is backgrounded. The Android Key Store offers hardware-backed key storage, key usage restrictions, and secure per-app sandboxing. Unlike manual AES encryption, Keystore keys are inaccessible even to root users and are protected from reverse engineering or memory dumps. This makes it the preferred choice for storing sensitive data like PINs and session tokens. Defend against brute force attacks on PINs, track failed attempts securely, and apply exponential backoff after several failures. Optionally, escalate to step-up authentication like OTP after repeated failures, and lock out the user after too many incorrect attempts. This strategy helps prevent abuse and keeps user accounts safe. In a multi-module architecture, define an app lock contract in the domain module, implement it in the core security module, and expose use cases to the presentation layer. Centralized navigation flows in the app module to ensure decoupling and testability. This structure keeps your app lock logic organized and maintainable. Biometrics alone are not sufficient for banking-level security. Always combine biometrics with other factors like PIN, device binding, or OTP for high-value actions. This layered approach ensures that even if biometrics are spoofed or fail, your app remains secure. When using biometric prompt in Jetpack Compose apps, always launch it from the activity scope, not directly from composables or view models. Use launch effect and remember updated state to avoid recomposition issues and memory leaks. This ensures your biometric flows remain stable and efficient. Persist the app lock state in encrypted storage to handle process death scenarios. On app restart, revalidate authentication and use save state handle to track transient input like entered PINs. This approach ensures that your app remains secure, even after unexpected terminations. Deep links should always route users to a validation screen first. Validate both the session and app lock state before allowing navigation to sensitive screens. If the app is locked, reroute to the app lock screen and resume upon successful authentication. Never allow direct access to protected content via deep links. For secure communication between biometric and PIN modules, use domain interfaces with sealed result classes. Communication should happen via dependency injection, not direct calls or reflection. This approach keeps your modules loosely coupled and easier to maintain. Testing biometric authentication in CI/CD pipelines or unit tests requires simulation tools. Use biometric prompt test util or test wrappers to simulate authentication outcomes. For view model logic, abstract biometric calls behind interfaces and mock them in tests. For instrumented tests, use UI Automator or mock dialogues with activity scenario rule. Centralize your nav host in the app module and expose only root strings from the core navigation module. Use Process Lifecycle Owner to intercept app foregrounding and trigger app lock. Avoid passing sensitive data in navigation arguments. Use ViewModel State or Save State Handle instead. When handling deep links in Jetpack Compose, always validate the session and app lock state before landing on protected screens. This ensures that users cannot bypass security by navigating directly to sensitive content. After unlocking, Clear the app lock screen from the back stack to prevent unintended access. Inject view models with HILT using HILT view model, scope per navigation destination. This approach ensures that authentication state is managed securely and efficiently across different screens. Test routes with Compose test rule and simulate biometric or PIN flows for comprehensive coverage. Keep authentication state in a shared view model or sealed class, propagated via composition, local or state hoisting. This ensures that the app lock state is consistent and accessible throughout your app, making it easier to manage secure flows and transitions. If a user backgrounds the app during a transaction, prompt app lock and step-up authentication upon return. This scenario ensures that sensitive actions are always protected, even if the user is temporarily distracted or interrupted. With Jetpack Compose, you can create a seamless and user-friendly lock screen. Use composable functions to display PIN input fields and handle validation. This approach not only improves user experience, but also makes your security flows more maintainable and testable. Follow a comprehensive security checklist. Use Flag Secure on sensitive screens. Store session tokens and PINs in encrypted storage, and validate all authentication layers. Regularly update your security logic to address new threats and comply with evolving regulations. A common interview question is how to prevent app lock bypass via recent tasks or screenshots. The answer is to use Flag Secure on all sensitive screens and monitor the app's lifecycle to trigger app lock whenever necessary. This demonstrates your understanding of both technical and practical security measures. Another interview favorite: why is Android Keystore better than manual AES encryption? Keystore provides hardware-backed security, key usage restrictions, and app sandboxing, making it far more secure than manual encryption, which is vulnerable to reverse engineering. To protect against brute force attacks on PINs, track failed attempts, apply exponential backoff, and escalate to OTP or lockout after multiple failures. This layered defense is essential for robust security and is a key point in technical interviews. When asked about implementing app lock in a multi-module architecture, explain how to define contracts in the domain module, implement in core security, and centralized navigation. This approach ensures decoupling and testability, which are highly valued in interviews. Can biometrics alone be used for banking-level security? The answer is no. Biometrics must be part of a multi-factor system, combined with PINs, device binding, or OTPs. This layered approach is essential for meeting security standards. To avoid memory leaks with biometric prompt in Compose apps, always launch from the activity scope and use Compose best practices like launch effect. This ensures your app remains stable and secure, even as UI frameworks evolve. Handling process death during app lock flow is crucial. Persist lock state in encrypted storage, revalidate on cold start, and use save state handle for transient input. This demonstrates your ability to handle edge cases in secure app development. To ensure deep links respect app lock state, always route to a validation screen first and check both session and lock status before navigation. This prevents unauthorized access and is a best practice for secure navigation. Secure communication between biometric and PIN modules should use domain interfaces and dependency injection. Avoid tight coupling or reflection for maintainable and secure code. This approach is favored in technical interviews for its clarity and safety. Testing biometric flows in CI/CD pipelines involves using test utilities to simulate authentication. Abstract biometric logic behind interfaces for easy mocking and unit tests, and use UI Automator for instrumented tests. This ensures your security flows are robust and reliable. Building a secure app lock for Android banking apps is about more than just a PIN screen. It's about creating a comprehensive security layer that respects user trust and meets industry regulations. By following best practices, using multi-layer authentication, and staying up to date with the latest security trends, you can build apps that stand out in the fintech world. Whether you're preparing for an interview or developing the next big banking app, these insights will help you deliver robust and user-friendly security.